Alright, good evening once again. Welcome to our tutorial class. So today we are going to be taking a look at a question under Jamb. So I will read the question as follows. So as you can see the question appearing on your screen, it goes this way. Some copper 2 sulfate pentahydrate was heated at 120 degrees Celsius with the following result. So we have mass of crucible equals to 10 grams, then mass of crucible plus copper 2 sulfate pentahydrate equals to 14.98 grams. We have mass of crucible plus residue, which is equals to 13.54 grams. Then how many molecules of water of crystallization were lost, given that the relative atomic mass of hydrogen is equals to 1, that of copper is 63.5, oxygen is equals to 16, sulfur is equals to 32. So you can see the options there from A to E. So you have to solve this question and get the answer. So how do we solve this question? So first of all, what you are going to do is you need to write down the mass of copper 2 sulfate pentahydrate, okay, is equals to, we have 14.98 minus what? 10. Now in this case we are subtracting the mass of crucible from the mass of what? Crucible plus the copper 2 copper 2 sulfate pentahydrate. So the mass of crucible is 10 grams, while the mass of copper 2 sulfate pentahydrate is 14.98. So to get the exact mass, you have to subtract the mass of the crucible from the mass of crucible plus mass of copper 2 sulfate pentahydrate, which will give you 4.98 grams. Okay. Then the residue is the anhydrous copper 2 sulfate. So residue mass here is going to be equals to 13.54 minus 10, that is, which is going to be equals to 3.54 grams. Now you subtract the mass of crucible plus residue, okay, minus mass of crucible. So you get the mass of residue. Is that taken? So this is the mass of crucible and this is the mass of crucible plus what? The residue. And I said our residue here is anhydrous copper 2 sulfate, as the case may be. So in this very particular moment, you now move ahead. We need to calculate the mass of water of crystallization. Okay, so mass of water of crystallization is now going to be equals to mass of hydrated copper 2, which is 4.98, minus the mass of anhydrous copper 2 sulfate, which is 3.54, which is equals to 1.44 grams. Okay, so that is the mass of water of crystallization. So the molar mass of copper 2 sulfate anhydrous is equals to 63.5 plus 32, okay, plus 4 times 16 in this case. So by the time you carry out the mathematical operation, you end up getting 159.5 grams per mole. Okay, is that taken? Good. Now in this case, we still go ahead and calculate the molar mass of water of crystallization, which is plus 16, okay, which will give us what? 18 grams per what? Mole, as the case may be here. Then after that, we need to calculate the number of moles N of anhydrous copper 2 sulfate, which is equals to mass of anhydrous copper 2 sulfate in grams all over the molar mass, so which is equals to 3.54 divided by 159.5. Is that taken? Which is equals to, we have 0.022 mole. Okay, we calculate also the number of moles of water of what? Crystallization, which is equals to the mass of water of crystallization, which is 1.44, okay, divided by the molar mass, which is 18. Carry out the division, we have 0.080. Is that taken? So therefore, we now say that, okay, the number of mole of copper 2 sulfate, okay, anhydrous, we said we have what? 0.022. Is that taken? Then the number of mole of water of crystallization is what? We have 0.080. Remember, this is in mole. Okay, so we divide by the smallest. Okay, divide the ratio, divide the ratio by the smallest, the ratio by the, okay, smallest. So when you do that, we now have, for copper 2 sulfate, we have 0.022 divided by 0.022, ratio 0.08, okay, 0 divided by 0.022. So 0.022 divided by 0, we have 1 ratio, then 0.080 divided by 0.022, you will have 3.63. So to the nearest whole number, we have 1:4. Is that taken? So which means that the mole ratio of anhydrous copper and the water of crystallization, we have 1:4, as the case may be here. So you get to realize that loss in, okay, water of crystallization after the analysis, loss in water of crystallization after the analysis was done is going to be equals to, since from the beginning we have 5 moles of water of crystallization before the analysis, so after the analysis we want to know how many molecules of water of crystallization is lost. So we subtract 4 from 5. Okay, so in this case 5 minus 4 is now going to be equals to 1. Okay, so the loss is just 1. So going by the option again in the question, if you observe, option A is the correct answer. I hope this helps. So thank you very much. Don't forget to subscribe to our channel for more important videos like this. So should in case you have any problem or any question that is giving you tough time as far as chemistry is concerned, remember you can always reach out to us. So thank you very much and remain blessed. Bye bye.